Hello everyone, myself Pawan, and today we are our machine learning series. And the first lecture on the ML is start with the intro part of the machine learning. And first, what is the machine learning? Machine learning is a type of the AI, or we can say it is a subpart of the artificial intelligence, and in which what happens, computer try to learn from the previous data. And the purpose of the machine learning to train a model on the basis of the previous data and to improve their performance. And as mentioned in the definition of the machine learning is a types of the AI that allow the computer to learn from the previous data and to improve the performance over the time. This is the main purpose of the machine learning. And there is no rule-based learning in the machine learning. They try to find out the pattern from the data, right? Now we have the definition of the machine learning. There are two beautiful definitions given by the two author about the machine learning. And the first one is the machine learning is enable a machine to learn automatically learn from the data, previous data, and to improve the performance from the experience and to predict the answer as per as the question given by the user. From the second definition, it's very famous definition of the machine learning by the author Tom. A computer program set to learn from the experience E with respect to some class of task T and the performance measure P. If it measures the performance P at task T and measured by the P, improve with the experience E. So what is the main purpose of this? We try to train a model on the basis of the previous data, and we provide some task to the machine. On the basis of the previous data, they give the answer to the model, and to perform their task, we try to improve the performance of the model. This is the main purpose of the machine learning, right? And now we start from the index of this. First, we have mentioned what is the machine learning. And the second two step of design the machine learning, what are the important steps to design a machine learning. Then we have the machine learning life cycle. Then we have the good feature point needed to design a machine learning model. Then we have the advantage of the machine learning. Then we have the disadvantage of the machine learning. Then we have the application of the machine learning and the how many types of the machine learning. And last week discussed in this video only the supervised machine learning. And the first we are designing the initial, then we move on the third one, this step in designing a machine learning model. This is very important. When we design a machine learning model, first we need the data for that. As we mentioned in the definition of the machine learning work on the previous data. So first point to design any ML model, we need the data for that. So first step to take the appropriate data. We have the number of resource present to take the data on such as we have some online repository, we have the different types of data collection approach. We are discussing our next video for this. Then we have the prepare the data. After getting the data, our second role to prepare the data. We have to prepare the data for the design model. And then number of steps to design the process, we are called the data preparation, and we call the data pre-processing. Means we are to prepare the data for the model training. And then we have to choose a model. After the preparation part of the model, when the data is prepared for the modeling, our next part is very important. We have to choose which is the best model for that. But different types of problem when we are take the data. Sometimes we have in case of the supervised learning, we have the data set is the classified data set. In some time we have the regression data set. When we have the both problem are different, then we are use the different types of algorithm for that. In the classified problem, there are different types of approach we have to apply. So the different types of model, like we have the logistic model, we have the SBM model, we have the random forest model, and for the regression problem, we have the different types of model. We have the linear regression models, we have the multiple regression models, we have the polynomial, with different types of model also present in solve the problem of the regression types of problem. Then after selection of the model, we also train the model. Before designing the model, we have to first train the model. We have to mention this point above this point. And what happened, we have to first design the model. We have to divide the data set into two parts. Either we have the train the model and the test the model. We are designing the model on the train value, and after the implementation of the model, we have to check the accuracy of the model with the help of the test data set. So before design the model, implement a model, we have to divide our data set into two parts, either in the train part and the test part. And we try to design a model, always we design the model on the train part, right? So in the train data, the size of data will be higher in the train value, and test value, the size of the data is the minimum we have to take. Then after that, we have to final model selection, we have to evolution matrix. With the help of this, we try to find out the score of the matrix, means the performance of the model. After designing the model, we have to check what is the performance of the model. And the classification problem, we have different types of metrics. We have the confusion matrix for that. We have the precision. We have the recall. We have a number of parametrics for this. In the regression, we have different types of problem to measure the performance of the matrix. Like we have the R2 square. We have the one of the important parameter for the regression problem. Then after that, we can also hyperparameters. We can improve the performance of the model. With the help of this hyper-tuning, we try to improve the performance of the model. As mentioned in the hyperparameter tuning model improvement. With the help of this hyper-tuning, after implement the model, we can enhance the performance of the model with the help of the hyperparameter, right? Then we have the last is the prediction. After this, when our model is prepared, and we are improve the accuracy with the help of the hyperparameter also. At the last, we give the unknown value to the model. With the help of this unknown value, we try to find out what is the output given by the model. So these are the useful steps for that. From data collection, then we have the data pre-processing. Then we have to train and test the data into two parts. Then we have the choose the best model for that, depend upon the types of problem. Either we have the regression problem and we have the classify problem. Then model selection. Then we have the evolution matrix. We find out about the performance of the model. Then we have to use the hyperparameter to enhance the performance of the model. At the last, we check the model on the unknown value data set. This is the main important step for the design any ML model, right? Then we have the machine learning life cycle. As you mentioned, we have defined, we have the problem identify. Whatever the model we have to design, first we have to identify what is the types of problem we have to take. Then for the specified problem, we have to need of the first appropriate data for that. The second most important step is the data collection part. Then we have the EDO of the data. Before designing the model, we have to apply the EDO of the model. The EDO is very beautiful key factor of the design the machine learning life cycle. Then we have the feature engineering. We have to prepare the data to prepare the model, right? We have to make a data in such a way we can design the best model for that, right? Then we have the model training. Then we have the last is the model selection. Then at the last we have the model score. These are 7 steps of the to design a machine learning model. First, problem identify, need of the appropriate data. Then we have to use the EDO of the data. Then we have the feature engineering. Then we have the model training. Then we have the model selection. At the last, we have the what is the important score matrix of the model, right? Before designing the model, we first need what the main characteristics are required for models, right? The model is not the overfit and the underfit. Before design any model, we have to keep 2 points in our mind. Our model not to be overfit and the underfit. And the problem for the overfit is the low bias and the high variance. When we design a model, it is the low bias model and the high variance. Then the problem of the overfit will be rise. If the model is the high bias and the low variance, we have the problem of the underfit. If the high bias and the high variance means our model is the both underfit and the overfit. Our best model is the model which has the low bias and the low variance. Now, what the meaning of the bias and the variance? Let's say in case of the classify problem, we have the 2 output features. Either we have the value 0 and 1. We have to classify the value to 2 parts. On the basis of the input value, the value is either 0 and the 1. And when we are take the data set for this, suppose we have the 1000 data value. Out of 1000, we have the 300 value of the 0 value and the 700 value of the indicate the output feature 1. So means there is a variance between the 200 between the 0 and the 1. So model is the variance is the problem of the variance. So when we design a model, we have to design a model in such a way, in the model, when we prepare a model, in the model training, the equal value of the output feature 0 and 1 enter in the model, right? The model should not be the biasness problem. Same in the variance problem. When we design a model, and after designing, we have to first check the model in the train value. Then we have to check the model in the test value. If the difference in the output performance of the trained data and the test data is very high, if the variation in the both of the features value is very high, then model is the high variance. So we have to design a model in such a way. Suppose the difference is very high, means model is overfit problem. Because difference between the trained data accuracy and the test data accuracy is very high. Then problem of the overfit. The best model is the model in which we have the low bias and the low variance. The difference between the train value, train accuracy and test accuracy must be in minimum, and there must be low biasness problem. Both the classify output feature have the very less bias value before designing the model, right? Now we have the advantage of the machine learning. As we mentioned, the automation of the repetitive task. I mentioned only 3 advantages here because the time is very less. We try to cover this video in 20 minutes. In the next video, we are more focused on that. I use only 3 important features of the advantage features of the machine learning in this video. First, the automation of the repetitive task. As we know, the ML model used train on the large data set. And for example, we mentioned in the PPT also, we have to be classify the email into 2 types of email category. Either they are the spam mail or not. And so we use the automation of repetitive task. For example, before this ML model, we have to apply this process repetitively to check either mail is a spam or not. But with the help of the ML model, they process the large data set and they can easily divide into 2 parts. Either the mail are spam or not. So there is no need of any human intervention. This is a very beautiful advantage of the machine learning, right? Then we improve the decision making. As we manage the ML model, very helpful to take the decision. And for example, we have the large amount of data set, and the ML model can easily analyze and quickly identify and provide the very rightful information in terms of to enhance the decision making. Let's suppose we have the customer sentiments. We have the number of customers, they are do the sentiments every day on any online purchase of item. And what happened? We have to at the last, we have to check what is the result of the 2 day sentiments about the customer. How many customers give the sentiments, positive sentiments, and they are the negative sentiments. So with the help of the decision making, they are used to analyze the large number of data set and to make the decision, the right decision at the end of the day. As mentioned in the PPT, ML algorithm analyze the vast amount of data, quickly provide the actionable insight that enhance the decision making. Right? In healthcare system, also very important role played by the ML machine learning. And the third beautiful advantage of the machine learning is the pattern recognize. They try to be, but one of the best features that the machine learning model are try to be abstract the main pattern from the image. For example, we are talking the image data set. So with the help of the ML model, we try to be abstract the main pattern of the, recognize the main pattern of the image, and to identify, we have to help to classify the data, right? So ML model identify trends and the pattern that are often invisible to the human. Sometimes, suppose we have the design and classify image, we have the number of the image, we have to classify the number of image. So with the help of this, they easily try to find out the pattern inside the image and classify the image on this basis of this, right? They are the main advantage of this. Then we have the disadvantage of the machine learning, right? The first disadvantage of machine learning is the data dependence. Because when we design any ML model, the data is an important part for that. Because the complete ML model are depend upon the data set. And the performance of the ML model sometimes heavily depend upon the quality of the quantity of the trained data, right? As mentioned in the early PPT also, sometimes the poor quality or biased data can design a model on poor data, and sometimes biased data. The accuracy model is not up to mark. So totally ML model depend upon the data dependent. If the biasness problem in the data, the model never give the right answer to us. So we have to first motive is to be main disadvantage we can say is the data dependency in the machine learning, right? Then with a high computational cost for that. The development and the deployment of the machine learning model require the very high investment in the infrastructure. Sometimes we need some computer resource, beautiful resource for that. And we also need some person who has the knowledge of the skill knowledge of the machine learning that can easily identify. So it's sometimes in the small business, it's very difficult to be establish the ML model for that. This is the main problem there. The risk of biasness. I repeat every time, the accuracy of the model depend upon the biasness of the model. If sometimes the trained data is contain bias value, this is a main disadvantage. So we have designed the model for that. After some time, when we check the accuracy of the model, what we find, the model is the bias, they are not provide the right answer to us. This is the main problem of the machine learning model. They are designed, there is no use, we can design the model. For the design of the model, there is no matter for the biasness of the model. But after designing, when we check the accuracy of the model, then we get the problem. Because the biasness create a very huge impact on the accuracy of the model, right? Same we have the overfitting problem. Sometimes the problem in the machine learning, we are designing the model is overfit. ML never we check the data, what the data we have. They simply we provide the data to the ML algorithm. They design the model, and they are not bother for the biasness of the data, and sometimes the overfitting of also. So the main problem that this is the main disadvantage of the machine learning. The biasness problem and the overfit problem is not solved by the machine learning, right? They simply design the model for that. So we have to design the model. We have to first check either they are the biasness problem and we have the overfit problem, right? And there are applications, beautiful application of the machine learning. Now the ML is used everywhere in the field, and we can suppose this self-driving car is a very beautiful example of the machine learning. Then we have the web search result and the social network website. Every website is Facebook, Twitter, YouTube. They are used the machine learning. Suppose we are use the any YouTube channel and run some video, then we can find the video. They try to be understand what the customer sentiments and give the same video in the next page. So what happens? They try to be use the sentiments, use the machine learning algorithm for that. We have some time web search result. They also use the machine learning work on that. We have the stock market price. They are totally dependent upon the nowadays on the machine learning. We can provide the prediction of the stock on the basis of the machine learning, and the banking sector also use the machine learning. Then we have the pattern recognize as mentioned earlier, plus PPT. In healthcare sector is very beautiful from last 4 and 5 years, and there is tremendous enhancement in the field of the machine learning in the field of the healthcare sector. And in the education also very useful, use the machine learning nowadays, and the forecasting of the weather also predict the what is the forecast of the our weather on with the help of the machine learning. And the last one in the agriculture sector, ML play very beautiful role from last few years. There are general some few applications of the machine learning we are mentioned here. Then we have the machine learning type. ML are classified into 4 types. We have the supervised machine learning, we have the unsupervised machine learning, we have the semi-supervised, and we have the reinforcement learning. There are generally 4 types of the machine learning we are used. The supervised is the machine learning. In this video, we are just give the overview of the supervised machine learning. And next video, I try to be both focus on the supervised and the types of machine learning, and unsupervised and semi-supervised. And the supervised machine learning, they are generally on the label data set. Means we have the input and output present in the data set. We can say also that. Supervised machine learning, they are work on the label data set, and in data set we have the input and output value. Both are present. They are called the supervised machine learning. Sometimes we have it is also classified in 2 parts. If we're talking for the supervised machine learning, they are classified into 2 parts, either the regression problem and we have the classifier problem. Then we have the unsupervised machine learning, there is no label data for that. Then we have the same supervised machine learning. Then we have the reinforcement, and some beautiful example of them. The house price prediction is the example of the regression problem. Then medical image, we have to classify the image. It's a classifier problem of the supervised machine learning. Then sometime we have the customer segmentation. We are try to make one cluster for that. The market basket analysis, the text classify. Then there's a general example of optimized marketing, the driverless car. They are all example of the reinforcement learning, right? Now we have the supervised machine learning, which you simply give the overview machine learning. As we mentioned earlier, in the supervised machine learning, we have the input and output data. Both are present in the data set. Simple example, we have the CSV, suppose we have the CSV format. In the CSV format, we have the input features and the output feature, both are given. And then we are called the supervised machine learning. But we also say that in supervised machine learning, the types of machine learning, it is we provide the sample level data set to the machine learning. They are mentioned as well, in which we provide the sample level data set to the machine learning. Data in the level form. Or we are predict the output on the basis of this level data set, right? And the supervised machine learning classified in 2 types, as we mentioned. First is the classification problem. In classification problem, we have the output target is divided into some category. We have to identify either the placement of the student as yes or no on the basis of their previous marks. We have the 3 input feature, their 10th number, their 12th number, their final engineering number, BTech number for example, if they are doing the BTech, all 3 features. At the last, we have to predict the answer on basis of 3 input, they are placed or not. So we classify in 2 parts, either they are placed or not. We are called the classifier problem, then with the regression problem. If output target value is the numeric value, suppose we have the house price. We want to predict the price of the house on depend upon the area of the house. Sometimes we have the area is the 100 square meter, the price is different. Then 150 we provide, the area price is different. To model every time predict the answer on the basis of the size of the house. They are called the regression problem. The output feature always be numeric value. They always change. In classify, either value is the binary classify in yes, no. Sometimes we have the multi-classify also. We classify in 3 parts. Suppose we have the temperature high, medium, low. It depends upon the data set and the problem, right? As mentioned in the diagram, we have the classify problem. We try to be number on this. We have the name of the student, the 12th number, BTech number final. We have placement yes or no. On the basis of this answer, yes, no, we are classify the problem, right? In the regression problem, we have the name 10, 12. Now we give the answer. We try to predict the model. Suppose we have the marks of the 10th and 12th. We try to find out what is my percentage in the BTech maybe. Yeah, for example, we give the number of the 10th. From the provide the number of the 10th, we want to be predict the number of the 12th with the help of the machine learning model. It's called the regression problem. There is no classify value in this. They are the numeric value. Either this is the output feature, they are the input feature. On basis of this input feature, we try to find out the what is the output value of this, right? So they are try to be find out the value in the numeric form, right? Then we have some classification models. The most popular classification models are the logistic regression. We have the SPM model and the name-based model, decision tree, random forest, and the KNN model. In the future, we try to be discuss all these classification problem models, right? Then we have the regression model. The most popular model are the simple linear regression model. It is very useful model and the first model of the machine learning in the field of regression, right? Then we have the multivariate regression problem. They have the polynomial. Then we have the decision tree, lasso, logistic. There are some beautiful regression models they are used for. And you are mentioned the decision tree. Decision tree is used for both classifying the regression problem also, right? And thank you very much. I hope you understand about the machine learning and what the advantage of machine learning, disadvantage of machine learning, and what are the applications of the machine learning, and generally types of the machine learning. We have the supervised, unsupervised, and we have semi-supervised and the reinforcement. And we try to be focused and try to be give aware about the supervised machine learning and either in the classifying the regression, the types of algorithm. And thank you very much.